We are Group 9, and we're designing the mill, mash, and lauter system in a brewery. So before going into design, it is important to understand the full process. First, the malts are put into the mill, which will grind them into a fine powder. Next, that powder is input into the mash at about 165 degrees Fahrenheit to activate the enzyme inside them, which will then break down the starches into sugars. The sugar water, which we refer to as wort, is then sent from the lauter, which will have a false bottom to separate the wort and the mash. So when designing this process, there are three variables that must be considered. First, the goal is to be as cost efficient as possible, which is self-explanatory. Second, space efficiency should be considered. The less land and property needed, the more cost-friendly this process will be. Lastly, process efficiency, which is referred to as how quickly the products can be produced. Obviously, this is going to directly impact the annual revenue.
Taking a look at the milling step, our design is suited for a 7-barrel beer system, and for a 7-barrel beer, it takes anywhere between 300 to 500 pounds of grain, depending on the type of beer that is being brewed. The team decided that it is best to allocate about 15 to 25 minutes for milling grains. The mill will be installed on a raised platform, as this will enable the help of gravity to transfer the milled grains to a mash tun through a welded trowel, and this will eliminate the need of a pump, and we will save costs in that area. The team found that an RMS2 roller mill is suitable for this system, as it is suited for a 7-barrel system. It mills about 1,200 pounds of grain per hour, and assuming a maximum grain mill of 500 pounds, it only takes 25 minutes, well within the time that the team allocated. The size of the mill is also not too big. It's 6 by 6 foot, as a small size is required to be installed on a raised platform. The cost of this mill only costs $6,400.
When designing the mash and lauter tons, cost and process efficiency were considered. So in order to save costs and equipment, we have the mash and lautering done in the same vessel. This vessel will have agitators to mix up the mash, as well as a false bottom to separate the malts and wort to act as the lauter. So the typical process time spent in the mash is about 60 minutes, and lautering typically happens at a rate of 1 hour for every 6 barrels. So we're estimating a 7-barrel process. This will take 70 minutes, as well as a cleaning process, which will take about 30 minutes, which will give us a total process time of 2 hours and 40 minutes. Also, all spent grain is going to be donated to local farmers to increase the sustainability.
The water heater that we are using is the Hubble Model HX/TX. It is a tankless water heater that has a compact size and is wall mounted. It comes in at 16 inches by 17 inches by 4 inches. It enables us to discharge 40 gallons per minute of hot water. And for our 157 gallons of strike water at 175 degrees Fahrenheit needed for our 500 pounds of milled grain, we are able to get this water in 4 minutes. The safety of our brewery is extremely important. One of our biggest safety features is the ventilation fan to expel dust generated during the milling process, because this milled dust is highly explosive, especially when gathered and left untreated. We have a vertical lift to avoid carrying heavy bags of grain onto the platform for the milling. Our platform has a hand railing installed to ensure that you do not fall off of it, and there's also a safety shutoff button for emergencies.
So to come down to the overall costs, the mill will be $6,400. The combined mash and lauter ton would cost $6,840. Our tankless water heater would cost $2,000, and our remaining major purchase would be for the vertical lift, which would be $3,000, bringing our estimated total to $18,240 for this system. Now, if we wanted to do a separate mash and lauter system, our cost would be around $25,000, and which we could offset a little bit by getting rid of the vertical lift, but we don't want to compromise safety to just save a couple $1,000s. So this is the ideal system that we're going to go for. So this here is a sketch of our process design. As you can see on the left, we have the grain lift, which would have railings to keep people from falling off when it's raised to the top at the platform. The platform itself would also have these similar railings going around this perimeter of it to keep people from falling off and injuring themselves. As you can see, the mill would be on top of this raised platform, and it would have the gravity-fed chute to the mash/louter ton, with the water coming in from the wall.